Alright, so question 3 says a projectile is fired at time 0 from point O at the edge of the cliff with initial velocity components of x being 50 meters per second and the initial velocity of y being 200 meters per second. The projectile rises and falls into the sea at point P. The time of flight of the projectile is 50 seconds. In figure 3.2, the y-coordinate of the projectile when its x-coordinate is 1,000 meters is closest to. Alright, so let's write out our components. V RV of x equals 50 meters per second, and our v of y equals 200 meters per second, and our time is 50 seconds. Why is it coming like this? Oh, what did I do here? No, go back to that. Okay, so let me just erase this. Okay, so our x will be v of x times t. So to solve for our time, we just divide one side by x, and then you're gonna have v of x. No. So we need to isolate t. So just by isolating t, we're just gonna have x over v of x. So the x is gonna be 1,000 meters, and the initial velocity is gonna be 50 meters per second. Meters will cancel out with meters. And we're gonna be left off with 20 seconds. Then the second formula we're gonna be using is for our y. It's gonna be vyt minus 1/2 gt squared. So our y is gonna be v, so it's 200 of our time, which is 20 seconds, minus 1/2, 9.8, 20 seconds squared. It's gonna give us 4,000 minus, when you calculate all of this, it's gonna be 1960. And when you subtract 4,000 minus 1,960, you will be left with 2,400 meters. So our final answer to this question is 2,040 meters, which corresponds to letter C.